My topic is basically to help the government decide where exactly you need to put the nature-based solution. So I have used remote sensing satellite images and to detect, like, where are the hotspots in the city and what's the pattern the hotspots are growing, or if there is any cool spots. So yeah, the study aims to examine one of the satellite towns in India. That is, the study area is Navi Mumbai. So, just to have a brief discussion about Navi Mumbai, because it's important to know the context and the rationale why I selected this area. So, Mumbai is one of the metro cities in India which is growing tremendously at a very high rate. And late in 1970s, the government decided that we need to have a parallel city which can help in decongesting the city of Mumbai. And that's how the very concept of Navi Mumbai came into existence. And um, the city was built just parallelly to the Navi Mumbai and connected by a very long bridge. So, and there's a creek that goes in that divides the two cities. And the study area that I have considered for my project is actually Navi Mumbai, which is on only Navi Mumbai is huge, so which is around 360 kilometers, and I have considered only the northern part of it, which is somewhere around 160 square kilometers. And again, it is mostly the urban, dominated by the urban areas. Now, just a brief about how the city is distributed. The entire city is based on administrative boundaries called as nodes, and there are around 8 nodes in Navi Mumbai. The methodology that I've applied for the study is, first I have retrieved the LST data. So LST is basically the land surface temperature data that you can acquire from the satellite image, and that is done from Landsat, and it has a 30-meter resolution. That's the free. That's the most accurate and a lower resolution image that we can see, and then the LST anomaly. So basically, LST anomaly deals with from the long term mean, like we took a 30-year data of LSD and how each year has been deviating from the long term mean, and then estimated the SUHI intensities. SUHI is the surface urban heat island intensity, and basically this was done how urban heat islands are defined as, how the temperature difference between the urban and the rural area. Surprisingly, we don't have a rural area here. So for my calculation, I've taken the area of the temperature of the vegetated areas, and then the retrieval of the population built up and anywhere, because we wanted to check how how the LST can be, how the temperature or the thermal condition can be related to the population growth, the built up growth, and the vegetation, and then narrowing down to neighborhood level, because this is a top down approach from here till this point. And then we realize, we cannot propose a nature based solution on a city based level, and because it doesn't have to be equal. You don't have to promote the same nature based solution to all part of the city, because all part of city would have different characteristics, and the nature based solution should be different. So then the nature based solutions were proposed, and further, it was simulated using NVMet to check how much is the temperature difference that can be seen. So this is the map for Navi Mumbai. So majorly, the yellow portion shows the built spaces covered in. I mean, almost the city is covered with the built spaces. We have a natural cover of mangroves on the side, and there is a hill that goes on this side. This actually makes the city more interesting because there are so many natural factors that affects the climate of this area. And this is a particular map which shows the growth of the trend of the heat. So the red spot marks the heat pockets within the city, and the blue one marks the cooler area. So it's interesting to see that, the southern portion, which has more of built up, still it is showing a cooler side. So there is something interesting that is happening on the set, and the same result can be, seen in the SUHI pattern as well. Now, this is the spatial growth. So what we did was we took the data from 1990 to 2020, which each 5 year, and we tried to identify the growth in each, this 5 year duration. So we see back in 1920, there were more of hotspot on the southern side, which actually reduced in 2015. And there is no nature-based solution that I propose here. till now. And over the on top of it, it has actually increased. The intensity is really high. The same happens with the urban heat island map as well. From green spots to really dark red spots on the northern and cooler spots of the southern portion. Now, if you look into the pictures, so this is another northern portion. So we have more of balanced surfaces. We have a lot of compact structures surrounding the site, which is actually slums. And then we look into the southern portion, which has green covers, which has a hill nearby, which is a vegetated hill, not a barren one like this. And the spaces you can see there is a difference in the build spaces can be actually identified. Now, we selected few pockets within the city, and I won't be discussing in detail because it talks about that there has been a growth in population, there has been a growth in urban heat islands, and a reduction in vegetation. But we selected some cities and some portions in the cities and tried to create what are the nature-based solutions which that could be implied on these sites. For example, if this is a settlement, I think this settlement went from a low rise to a high rise, and however, the vegetated space also grew from when the vegetative index was 0.08 to 0.5, and it has subsequently reduced the urban heat islands here. So this was another case which was for a slum, and what the proposal of NBS we took creating vegetated trellis in the passage between the buildings, adopting to cool roofs and walls, and this was another study which is actually a commercial street. So if you look into the images, it's completely a concrete jungle. And then the population has increased, not much, but yeah, this is more of commercial spaces. However, the SUH has grown like it is tremendous from 4.04 in 1990 to 10.93 during the 2015-20 period. And yes, there hasn't been any vegetated growth over here. So we proposed an NBS which would compose of rooftop vegetation. Now, one of the areas that I selected was 5 meter by 5 meter area, 5 kilometers by 5 kilometers area. So here there is a slum, there is a residential body here, and then there's on the B side is actually a road, and then you have a commercial body. So the proposed intervention becomes rooftop greening on the residential area, the street plantation on the open areas near the road, and then rooftop greening on the commercial area. Yes, I restricted myself to rooftop greening as an NBS solution because of the constraint in the we just have it's compact area. There's no space and ground, and some few trees wherever possible. So the result actually showed that the mean rate. This is the initial. This is the residential area. This is the street, and this is the commercial area. So I cut sections in two different panes. So the first section was cut at the 40 centimeters scale to check what is the mean radiant temperature that could be experienced at the at such a low level. So it was seen like the areas which were pink is actually somewhere around 50-55 degree, and with the intervention it came down, the temperature mean radiant temperature came down to somewhere around 46-43 degrees Celsius. Similarly, on top, because the rooftop plantations were proposed, so the temperature that would be seen on top of the roof is initially, which was around 50-52, it came down to somewhere around 42-43 degrees Celsius. And then comes the PET, that is the physiological equivalent temperature. There was a change of around with the proposed intervention. There was a change of around 2 to 3 degrees Celsius at both at 40 centimeter scale as well as at the 18 centimeter scale. So basically, the study was done in order to help the government identify that you propose a nature-based solution, but you have to look into the climate action policy because Indian government at its local state is actually presently looking into creating climate policies for the cities. And this study can actually help them identify which our neighborhood needs a priority, which our neighborhood needs a climate action policy that has to be implemented at a very fast pace. Thank you.
Thank you, Anusha. We have time for at least one question for Anusha. If anybody has an initial one for her. Wonderful.
My
It's on.
question is, you showed the analysis done at a surface level of zero point 0.4 liters. Yeah. So, do you intend to reduce the surface temperatures through these NBS, or is it intended for reduction or for enhancing the thermal comfort, which is ideally usually done at a very, very more higher level? Okay, so the reason is I use Landsat imagery. So Landsat image gives me the surface level temperature. So that was one reason why that 40 centimeter, the results for 40 centimeter was shown. But parallelly, I've shown result for the rooftop also. So it does mean, the temperature, the difference in temperature was seen in both the cases. So which was around, even with the rooftop plantation also, at the surface level, you can experience a temperature difference of 4 to 5 degrees Celsius.
Other questions for Anusha? I can ask you a question. It's going to be another environmental question, so I'm going to apologize in advance for that. When you were running the model, were you pulling data to drive IndyMet from the airport at Mumbai or data near the sites?
Near the sites.
Okay, so you have like instrumentation in
there
place.
is an instrument. Thankfully, there was an instrument near to the state to the study area.
Okay.
So the data, the temperature data, the wind data was taken considered from the data given from the municipality itself.
Okay. Did you have any instruments set up within the neighborhood itself to see afterwards if IndyMet was similar to the results?
But this is a proposal because
Okay.
yeah, this is not implemented. This is not implemented. It's
Sure.
just to just to tell the government that if you implement these ideas, you can bring down the temperature, mean radiant temperature or perceived temperature. Though I need to mention that also, the in my case, the NMS results showed that air temperature, it did not have much effect in the air temperature. However, how you perceive the space, there was a temperature difference. See, like 10 degrees Celsius.
Kind of question from Chevy.
Thank you for your presentation. Yeah, so I was just going to I wanted to ask around the practicality of this finding. Okay. So from your study, like one of your recommendations is the implementation of green, green buildings, right? And also you mentioned that in those areas, the reason why you were proposing greenery on those buildings was because of the compactness of the buildings. This has been the case in most informal settlements, especially in the US South. Um, yeah, so based on my experience from sub-Saharan Africa, yes, green buildings is fancy models, but the reality of it is difficult. Number one, because of the cost of implementation. Um, Also, you need irrigation, and most places it's not realistic. So I just wanted to ask you whether whether you have thought about your thoughts basically about the practicality of this solution within the formal settlement context.
Okay, with the informal settlements, you are asking. Okay, so there is a case study that is done in Ahmedabad. So, initially it was discussed, NPS is not about providing green spaces. So, in one of the informal settlements, you cannot propose. It's quite expensive to propose a green roof or green facade. However, there were solutions like they use sustainable materials, which is actually made of recycled. I don't know the technical details of it, but each they provide a roof, a covering on top of roof, which is quite thick, and it is made up of recycled materials, which helps to reduce the temperature on the surface of in the interiors of the building, as well as the reflectance also has a it also has an effect on the reflectance also, like it can help. It doesn't it reflects back all the solar radiation that is if you install those roofs. So this is something which has been practiced in the informal settlements of India. And another proposal was to, plant vegetated trellis across, across the open spaces in informal settlement, because that is cost effective. They use the locally available materials, and then and they install the vegetated areas in order to reduce the temperature. So these are measures that would be proposed in case of informal settlement. However, the areas where I have proposed the vegetated roof, frankly speaking, while talking to the locals there, people are reluctant to adapt to it. Reason being, because of the amount of care that you have to give to the vegetation, also for the maintenance of it. However, we have NGOs who are working to reduce the cost of it, as well as to improve the efficiency of these roofs in terms of the leakages and the root penetration. And we have a lot of such agencies within Mumbai and Navi Mumbai who are actually doing that. So I am working. This is the final part of my thesis, to work on the cost effectiveness and what would be the cost to to implement these solutions, so that actually government can help the city to become commonly comfortable. Thank you.
Thank you so much, Anusha. We have a few minutes left because there isn't a final talk in this session, but I think given that multiple talks have had multiple